how to design this model. And this is what I do. On top of all of that, there's an issue which, in my opinion, is difficult to get around. An anomaly detection system will tell you that there's something wrong. No more, no less. What's wrong is your guess. If you are lucky, and if your system is particularly well built, it will also tell you how it detected something anomalous. For example, it will tell you, look, this variable is anomalous. So you can have some hints for figuring out what's going on. But in most cases, you will never get an alert which is as precise as the alert of a misuse detector. Misuse detector says to you, this particular vulnerability has been used on this particular host, and guess what? Your host was vulnerable, and guess what? The attacker got back a shell. That's way better if you want to do reaction. So, anomaly detection systems, until now, are not very useful for intrusion prevention. In my lab, we study anomaly detectors based on unsupervised learning. Unsupervised learning is a nice term. What is a learning algorithm? It's a very simple thing. It's any type of algorithm that can improve its performance while you use it. The more you use it, the more you train it, the better it gets at performing its tasks. Learning algorithms are divided into two different sets. Supervised ones are the ones where you train the algorithm by giving it examples of inputs and outputs. For example, the basic multi-layer perceptron, the neural network that you have studied if you have studied anything in neural networks, it's the simplest form of neural network, is supervised learning algorithm. You show it samples of inputs and results, input and result, input and result, then you give it an input and you make it calculate the result. On the other hand, there are unsupervised algorithms that can learn on unlabeled data. They can learn on data which has not been tagged. And they are very curious because one of the things these unsupervised algorithms are very good at is detecting irregularities in data and flagging whatever behaves irregularly. Remember something? An unsupervised learning algorithm is very, very similar to the basic definition of intrusion detectors. I've already presented here in this hotel my network-based intrusion detection system. Today I will talk about host-based intrusion detection. What's the state of the art? Host-based, anomaly-based intrusion detection, lots of research on it, gazillion of papers, everyone has written one. Every single student of a computer security course has written an intrusion detection system using whatever algorithm he had at hand. So, let's focus, because otherwise we will get lost. I don't have the time to explore everything. One observed feature, the sequence of system calls a process makes. Great feature. Tells you everything you want to know. What files does your process access? What does it do with them? It tells you everything. The sequence of system calls called by a process through its life is very indicative of what the process does. In fact, those of you who routinely debug programs may have used strace or something like that to understand what the heck is going on in a program. There's a lot of studies on this feature, on sequence of system calls. The base idea is that for each program, I can somehow characterize the sequence of system calls it normally performs so that I can detect deviation and flag them as anomalies. There's a lot of earlier studies, and they used basically everything. Markovian algorithms, wavelet transforms, neural networks, finite state automata, n-grams, whatever they had at hand, just on the sequence of calls. Of all these models, the most interesting one is the Markovian model, because, in fact, it comprises most of the others. Neural networks are a case apart, and n-grams are a case apart, because they would be comprised by Markovian models, but only by a particular type of Markovian models. But the interesting turning point is asking ourselves, well, but is the sequence of system calls really so interesting? It is. If someone gets to execute its shellcode in the context of your process, probably its shellcode does not match the sequence of system calls that you normally make. But on the other hand, what usually doesn't match between the action of an attacker and the action of the real program may not be expressed by the sequence as much as by the arguments of the calls. And so why didn't anybody think of characterizing the arguments of the system calls? Because it's difficult. It's complex to handle arguments that are different. They're heterogeneous. It's difficult to handle them automatically. The only attempt was work done by Giovanni Vigna and others called Syscall anomaly or libanomaly, libanomaly.org. But let me step back for a single moment. One of the basic tasks for unsupervised learning algorithms is time series learning. What's a time series? A time series is a sequence of observation over time. For instance, you observe the temperature of Las Vegas over a year. 40 degrees Celsius, 42 degrees Celsius, 41 degrees Celsius, and so on. Once a day, once every 2 hours. You will have a data which is a time series. So, if a syscall is an observation, a time series of syscalls is a program. A program is a sequence of syscalls. So, if this time series of syscalls is really a good description of the behavior of the systems, and how could it not be? It is a good description. Attacks should be probably turn out to be outliers. What's an outlier? An outlier is an observation in a time series which is so different from the others that you begin to wonder that maybe you were drunk when you did the measurement, or something else funny happened. An outlier is something that is totally wrong in the context. So, what's the problem? We have time series of system calls. We analyze the time series of system calls. we find out outliers. Anomaly detection done, problem solved. Where's the problem in this? First problem, traditional definitions for finding out outliers in time series are based on a simple assumption that the time series is made of a sequence of continuous values. So, values that are real numbers. System calls are not real numbers. They are what we would call qualitative or categorical values. Open is different from another system call, from a read, from whatever. But really, you can map those system calls to numbers, but these numbers do not have a real meaning. If you map open to 1 and set UID to 2, this does not mean anything on the fact that these two system calls are close. So, all these definitions based on the distance between numbers cannot be applied. The only approach which gives us a way to define time series outlier detection for categorical values is Markovian models. What's a Markov chain? A Markov chain is basically, well, there's the definition over there, but I don't really want to lose everybody of you. So let me just sum up in this way. A Markov chain is a stochastic process, which means a process which has random results. It does not go always the same way. Where there are a finite number of states, well, this sounds good. System calls are finite. There's a stationary probability of transition from one state to the other, so it doesn't change over time. During time, you move on the model, but the model itself does not modify. And it has the Markovian property, which means that what happens in the next step depends only on the k most recent steps. And usually, we call a Markov chain a Markov model of order 1. So a Markov model where you take into account only what has happened in the step before. A first order chain has transition probabilities which can be expressed on a very small matrix with S rows and S columns. Probability from A to B, from A to C, from C to A, or C to B, etc. It's a square matrix with S rows and columns. If you add in the nth order property, which means that you keep track of the n most recent states, you need S to the nth by S to the nth rows and columns, which means that each step you add into the description complicates the model in an exponential manner. So, for these reasons, most of the studies and